Question number 24. The strength of a H2O2 solution can be expressed as the volume of O2 produced at standard temperature and pressure. For example, a liter of 20 volume strength H2O2 solution will produce 20 liters of oxygen at STP. According to this reaction, assume that 1 mole of gas has 22.4 liters volume at standard temperature and pressure. A bottle labeled X contains H2O2 solution. When 25 of this solution X was titrated with 1 molar KMnO4 in the presence of dilute sulfuric, the volume required to reach the end point was 25. The volume strength of solution X. So they have given a titration. So let's simplify the titration first. The reaction takes place with KMnO4 and H2O2. So the half reactions will be MnO4 minus goes to Mn2 plus in an acidic medium. The purple color turns into colorless. So in order to balance the redox reactions, first we must balance the element which changes its oxidation state, which will be manganese, and it is already balanced. Then we have to add water to balance hydrogen. So we have to put 4 water here. And the hydrogens are unbalanced now. To balance the hydrogens, we have to put 8H plus to the left side, and to balance the charges, we have to put 5 electrons. In this side, you have plus 2 charge. In this side, you have 8 minus 1 is 7, plus 7 charge. So we have to neutralize 5 of them. So we have a plus 2 charge in the left side as well. That is why we put 2 electrons here. Now H2O2 will be oxidized to oxygen gas. To balance hydrogen, we have to put 2H plus. To balance charges, we have to put 2 electrons. Now in order to add these two half reactions together, we have to multiply this reaction by 5. We have to multiply this reaction by 2. We use this 5 and this 2. So the final reaction will be 16H plus 2 into 8 is 16, 2 MnO4 minus, and 5 H2O2 gives 5 O2. You don't have to write the whole reaction here, but for the understanding, I'll write the whole reaction. You just need only this stoichiometry. And 10H plus, 2 Mn2 plus, and 8H2O. You can cancel off these H plus if you want. You can put 6H plus here, but it is not necessary for this calculation. Now the stoichiometry between permanganate ion and H2O2 is 2:5. So let's calculate the MnO4 minus amount. They have said here 1m KMnO4 volume was 25. So the number of moles of KMnO4 will be 1/1000 into 25. This is the amount of moles from KMnO4. And H2O2 moles will be, its concentration is X and its volume is 25. That X is from the 20 volume strength, so we cannot take X as the molar concentration. Let's take it as C, the H2O2 concentration as C. Now this X is in a different type of concentration. This is from moles per decimeter cube into 25. Now this ratio is equal to 2:5. That is obtained from here. Now let's simplify this. We can make it a division here. So this 1/1000 will be cancelled off. This 25 will be cancelled off. So 1/C will be equal to 2/5. So C will be 2.5 moles per decimeter cube. So this is the molar concentration of hydrogen peroxide. Right, therefore we can calculate the amount of H2O2 we get from this solution. So let's calculate the number of moles of H2O2 of this 25. number of moles of H2O2 will be 2.5 over 1000 milliliters contain 2.5, so how much will be contained in 25? So it will be 62.5 into 10 to the power minus 3 moles. Now this amount of H2O2 moles will give how much of oxygen? Now don't use this equation to calculate the amount of oxygen from H2O2. We can't use this because they have already given which reaction should be used in order to calculate the amount of oxygen. It is this equation. Now according to that equation, 2H2O2 gives 1 oxygen. So that means whatever the amount of H2O2 we have should be divided by 2 in order to get the amount of oxygen that this solution liberates. Therefore, number of oxygen will be half of this, 62.5 into 10 to the power minus 3 divided by 2, which will be 31.25 into 10 to the power minus 3 moles. Right, now this amount of moles is given by 25 volume. See, the solution of this H2O2 is 25. Now 25 milliliter of H2O2 gives this amount, 31.25 into 10 to the power minus 3 moles of oxygen. So this is the relationship. Now the volume, the X volume strength, the volume strength of solution X. Now the X volume strength should be calculated for 1 decimeter cube. Now we have to calculate the volume of oxygen. Now they have given 22.4 liters will be representing a 1 mole of gas. Now we have 31.25 into the power minus 3 amount of moles. So let's convert this into volume. So 25 milliliter of H2O2 solution will give 31.25 into 10 to the power minus 3 into 22.4 liters of oxygen. So this amount of moles of oxygen will be equal to this amount of liters of oxygen. So this is our relationship. Now the concentration, the volume strength is defined or expressed in terms of how much of volume of oxygen will be liberated from 1000 milliliters or 1 liter. So 1 liter will liberate this amount, 31.25 into 10 to the power minus 3 into 22.4 divided by this 25 into 1000. I hope you can understand. If you don't get that, just rewatch this video again. Now I'll quickly go through this process again. Now the volume strength 20 means 1 liter of H2O2 liberates 20 liters of oxygen. So if some solution, let's say if a particular H2O2 solution, when we take 1 liter of a solution, liberates maybe 50 liters of oxygen, that means its volume strength is 50 volume. Therefore, we have to calculate how much of oxygen can be liberated from this given solution. Now for that we used a titration. That titration gave us information about how many moles are there in 25 milliliters of H2O2 solution. So we calculated the amount of H2O2 in the 25 milliliter, and then we calculated how much of oxygen can be obtained from that amount of H2O2. That was this value. This is the oxygen amount that we can obtain from the 25 milliliter of H2O2 solution that they have given, which was labeled as X. Right. Then the 25 milliliter of H2O2 gave this amount of moles of oxygen. then we have to convert this amount of moles into volume. Now they have said 1 mole is equal to the 22.4 liters. So that means 2 moles will be 2 into 22.4. So 5 moles of oxygen will have 22.4 into 5 liters. Likewise, this amount of moles will have this into 22.4 amount of liters of oxygen. That amount of oxygen liters was obtained by 25 milliliters of the H2O2 solution. So we have to calculate how much will a liter of H2O2 solution give the volume of oxygen. So it will be this value. When you calculate this, you will get 28 liters. So that will be our answer. Therefore, the answer is fourth one. But in the exam, they gave all the answers as correct ones because I think there was a translation mistake in the Tamil medium paper, because I think I saw that in the Sinhala medium paper also they had the same question, but for some reason they gave all for that. We can calculate it actually. All right, so let's move on to the next question.